Good morning. Today we are going to be dealing with physics and the topic Hooke's law. Now, Hooke's law states that Hooke's law was propounded by a scientist, an English scientist to be precise, called Robert Hooke. And he said, provided the elastic limit of a material is not exceeded, the deformation, that is the extension of the material, is directly proportional to the applied force. That is, tá a bá ṣì ń stretch elastic material tí ò bá tíì kọjá elastic limit ẹ̀, bó ṣe ń extend sí yẹn is that the higher the force, the higher the extension. Bá a bá ṣe ń apply force sí, bẹ́ẹ̀ náà ló ṣe máa extend sí. Gbogbo kiní wọ̀nyẹn dẹ̀ ló clear because bá a bá ṣe ń increase the force on that material, náà ni kiní yẹn ṣe máa extend sí. So as you are applying force on it, it's going to be extending. That's the breakdown of the law in Yoruba. Now, ẹ jẹ́ ká wo nǹkan tó sọ yẹn. Ó ní force is directional to the extension, whereas force can now be equals to Ke, whereby we know that this K is a constant. Constant ni, and the constant is known as elastic constant. Constant. F will be equals to force. Sometimes wọ́n máa ń pè ní load, wọ́n máa pè ní load ńgbà míì, whereas E is known as the extension. Extension yẹn náà dẹ̀ làwọn kan máa ń pè ní deformation. So this is just the breakdown of that Hooke's law. Now, ó sọ pẹ̀lú àwọn experiment tó ṣe. Experiment ń dẹ̀ ni this is a particular graph, and they all come up with this graph, and this is a force, this is the extension. Now, this is the material. Tá a bá stretch material yẹn tó bá dé level B, A yìí náà pè, tó bá dé point A yìí náà pè ní proportionality limit. Proportionality limit. That is when the material is still obeying Hooke's law. Ó ṣì ń obey Hooke's law lásìkò yẹn. Now, tó bá ti wá dé bí báyìí, tó bá ti dé point B yìí ni wọ́n pè ní elastic limit. Now, ní point B yìí, ó ti dé elastic limit nìyẹn. Anything beyond it kò ní lè obey Hooke's law mọ́. Now, tá a bá ti wá stretch ẹ̀ kọjá B yìí tó dé point C yẹn náà pè ní yield point. Yield point yẹn ó mean pé at that point the material will no longer obey Hooke's law again. It cannot return back. Tàbí tá a bá kì í ṣe pé kò ní obey Hooke's law, but tó bá ti lè dé yield point, ó máa di plastic. That is, tá a bá stretch ẹ̀ kò ní ní oore ọ̀fẹ́ àti padà sí original position ẹ̀ mọ́. So at yield point, the material loses elasticity and it becomes plastic. So tá a bá stretch ẹ̀ kò ní ní oore ọ̀fẹ́ àti padà sí original position ẹ̀ mọ́. Now, anything stretching beyond it is going to break. That's why they say this one is a breaking point. Let me take this one as a breaking point. So C, our C will now be the yield point, whereas our C will become the yield point, whereas our point D will now be breaking point. So C is the yield point. I told you that's the place where it's going to lose its elasticity, and that one is a breaking point. So it's going to break. So it's going to break at that point. So that's the rules. And let's see whether we can solve one or two examples on Hooke's law. Now, let's look at this question. A force of 0.8 Newton, 0.8 Newton, and that means let's take as force as 0.8. Now, stretches an elastic by 2 centimeters. So that means the extension is 2 centimeters. So we can convert this one to meter, and that will be 0.02 meter. So that's it. Find the elastic constant of the spring. So we believe that F is equal to Ke. That means K will be equal to what? F over E. And that's what? 0.8 over 0.02. So this one is going to be, is it not 40 Newton per meter. So that is the elastic constant. Now let's take the second question that describes Hooke's law, and that's the second question. Say, a force of 2 Newton. So a force of 2 Newton stretches an elastic material by 30 cm and 30 mm. Let's quickly do that. That will be 0.03 meter. So the next one, what additional force will stretch the material by 35 material 35 mm? So let's take another one. 35 mm. That's what 0.035. So let's see what we can do there. Assume the material is not exceeded. Now let's look at this. We need to firstly use this first information to get the elastic constant because it's the same material, but the only thing is that in this case it is 35. They are telling us that what force are we going to apply. This 2 Newton is the one that is going to stretch the material to by 30 mm, but this they are now looking wọ́n wá 2 Newton yìí. Ẹ jẹ́ kí n sọ ní Yorùbá jàre, mo ti gbà pé Yorùbá ni a fi ń kọ́yàn bíbà. Now nǹkan tó ń sọ nínú question in precisely ni pé nígbà tí a apply force 2 Newton sórí material tó wà ní question yìí, kíní stretch by 30 mm, but wọ́n wá ní pé force wo la máa need tá bá máa force wo la máa apply sí material yìí again tó máa jẹ́ kí kíní yẹn stretch wọ 35 mm. Nǹkan tó wá ń sọ wọ́n ní additional force wo ni, that is 2 Newton kan ti wà nílẹ̀ tó yẹ pa apply sí material yẹn tó fi stretch by 30 mm. Now wọ́n á ní force wo la máa wá fi kún tí stretching yẹn máa fi wá wọ 35 mm. No, so ìyẹn rọrùn. Ká fi first information ká fi gbé elastic constant jáde. Ìyẹn dẹ̀ rọrùn, a dẹ̀ gbà pé K is equal to what? F/E. So therefore a lè sọ wípé 2 divided by 0. Or ẹ má ti jẹ́ ká mi fẹ́ ká lo kíní, mi fẹ́ ká lo SI unit, ó máa gbéra ẹ̀ jáde láìpẹ́. So ẹ má yẹ ká lo SI unit, ẹ jẹ́ kí n lo mm yìí náà, ó máa rọrùn náà bí eléyìí. So this one is going to be 1/15 Newton per mm. So mi ní lo Newton per meter for now. So 1/15 Newton per mm. So màá gbé ìyẹn wọ bíbà yẹn, ó máa rọ̀ mí lọ́rùn láti ṣe báyẹn. Náà ẹ ká wo ọgbọ́n tá a máa dá sí yẹn. So a ti mọ kíní elastic constant yìí. Elastic constant yìí òun náà ni níwọ̀n bá jẹ́ kí material kan náà ni, òun náà ni a máa lò ní second information torí is the same material, so they are going to have the same elastic constant. No matter the stretching, no matter the force, constant will still remain. So ẹ ká wò ní the other question. So a ti mọ̀ pé now force is what? Ke. So we need a force. Force will now be what? What's the K? 1/15. Now a nílò eléyìí torí millimeter la lò lẹ́ẹ̀kan, so a sọ pé times 35. So this one will just be what? So a lo eléyìí báyìí, this one is now going to be 7/3, which is 2.33 Newton. So 2.33 Newton ló máa jẹ́ force yẹn. Ṣé ẹ mọ̀ pé 2 Newton la add mọ́ lẹ́ẹ̀kan la lò lákọ̀ọ́kọ́ tó fi stretch wọ kíní, but tá a bá máa lo eléyìí 2.33 Newton ni. So kí la nǹkan tó mì báyìí, nǹkan tó wá ń béèrè lọ́wọ́ ni pé additional force. So ó mì pé force wo la apply sí 2 Newton tó fi wá wọ tí kíní yẹn fi máa stretch wọ 35. So ó mì pé the additional force will now be 2.33 Newton minus 2, and that's what? 0.33 Newton. So that's just the answer to the question. I hope you find the video so interesting, and I believe I've passed a lot of message. If yes, subscribe to our channel, like our video, and share it to your loved ones. Thank you so much. God bless you.